1213 intersection of three sorted arrays. Given three integer arrays, array 1, 2, and 3, sorted in a strictly increasing order. What does it mean, a strictly increasing order? It means there is no duplicate number, because it says it's strictly increasing order, right? So it's giving us the hint that there are no duplicates. Return a sorted array of only the integers that appear in all three arrays. So in this example, as you see, we have three arrays, and the output is going to be 1 and 5, as we have 1 and 5 in all the three arrays. And in this example, we have three arrays are given to us, and the output is empty because there is no common elements between these three arrays. Okay, let's see how we are going to solve this problem. To solve this problem, what we are going to do is we need to check all three arrays and see if we have like a common element in three of them. What we can think of is we can use three pointers that will start from the beginning of the three arrays, and it will traverse the array and try to find common elements. And how can we do that? Let's go through this example. Let's say we have these three arrays. Let me copy and paste it here. There we go. We have array 1, we have array 2, and we have array 3. Let's say we are going to use three pointers, right? We have pointer 1 here, and then we have pointer 2 here, and then we have pointer 3 here. Okay, we start traversing, and if there is a common element, we are going to add it into the output array. Let's say we have an output array, and if we see a common element, we are going to add it here. P1 is pointing at 1, P2 is pointing at 1, and P3 is pointing at 1. So I'm going to add 1 here, and I'm going to move one step forward for all the three pointers because it was common. And then I check here, we have 2, 2, and 3. What should I do here? So one thing that I know is if the element that I have at pointer 1 or pointer 2 or pointer 3 is smaller than the other pointer, we know that there could be no way to find a common element. So we need to move forward the pointers that are pointing at a smaller element. So as you see, 2 is smaller than the biggest element that we have here is 3. 2 is smaller than 3, and these 2 is smaller than 3. So I'm going to move this one step forward, and I'm going to move this one step forward, but we don't touch this because this one was bigger. And then I compare these three. Are they equal? No, they are not. And then now I will find the biggest element again and see if like I need to move any of these pointers. So the biggest element, we have 3, 5, and 3. The biggest element here is 5, so I need to move the pointer 1 and pointer 3 one step forward. I move them one step forward. So now I will find the biggest element again, 4, 5, and 4. What is the biggest element? 5. So I need to move P1 one step forward and P3 one step forward. What is the biggest element? As you see, they're all 5, so we can add it to the output array, and then we can move them one step forward, one step forward, and one step forward. As you see, the pointer 1 is pointing out of the array, so it's out of the indices, and what we are going to do, we are going to return the result. So let's see how we can code this. One thing, the first thing first, we need to define three pointers: pointer 1, pointer 2, and pointer 3, right? And they all are going to start pointing at index 0 at the beginning. Then we need to have a while loop that we should have this condition: as long as P1 is smaller than the length of array 1, because we want to be within range, and P2 is smaller than the length of array 2, and P3 is smaller than the length of array 3. This way, we are going to end this loop if all these three conditions are not valid, right? And when it says like P1 is smaller than, as long as P1 is smaller than length of array 1, in this case, the length of array 1 is 1, 2, 3, 4, 5. And P1 is index start from 0, so it's 0, 1, 2, 3, 4, and now this is 5. So it's not smaller than 5, so we need to end this while loop. So this way it helps we go based on the smallest array that we have, and then we check if the value that we have in our array 1 at P1, if it is equal to array 2 at P2, and if it is equal to array 3 at P3. So it means we have a common element in all the arrays. What we are going to do, we are going to intersect list. We are going to have an intersect list. We are going to append this element. It doesn't matter because they are all common. I can use any of these elements to the array, and we are going to move one step forward all the pointers. And P3 one step forward. And what if they are not equal? So if they are not equal, it means it's like they can point at any numbers, but they are not equal. What I'm going to do, I get the largest element, because that's what matters, right? Max array 1 at P1 and array 2 at P2 and array 3 at P3. I get the largest element. Then I'm going to check every single pointer that we have, the value that we have at every single pointer, and compare it with the largest element. And if it is smaller, I'm going to move it forward. I'm going to say if array 1 pointer 1 is smaller than the largest, then move P1 one step forward. And then I'm going to say if the array 2 P2 is smaller than the largest, I'm going to move forward P2. And then I'm going to say if array 3 P3 is smaller than the largest, we are going to P3 is going to go one step forward. And after we are done with this while loop, we are going to return the intersect array as a result. Sorry, let's run this code. And there we go, it works. So the time complexity for this, as you see, we are going to traverse this array only once, is going to be linear, and the space complexity is constant, as we are not using any auxiliary space along the code. And the only space that we are using is the output, which when we are calculating asymptotic time and space complexity, we don't consider that. Thank you.